Bronsted acids and bases. Bronsted acids are proton donors. Here are some examples of binary acids: hydrochloric acid, hydrosulfuric acid. Notice that it contains a hydrogen and a different element. There's a hydro prefix and an ic suffix. The other type of acids are called oxyacids. Here are some examples of oxyacids: nitric acid, nitrous acid, and hypochlorous acid. Notice that these types of acids have a hydrogen, an element, and one or more oxygens.
Acids and bases continue on the next slide.
Bronsted bases. These are proton acceptors. There are two types of Bronsted bases: anionic or neutral. Here are some examples of the anionic Bronsted bases: the chloride ion, the cyanide ion, the acetate ion. Notice that these Bronsted bases are negatively charged and require a countercation or H+ ion to become a neutral molecule. The neutral Bronsted bases have no charge. Some examples are oxygen or nitrogen-containing molecules, such as H2O, water, NH3, ammonia, or amines, such as triethylamine.
This slide shows the qualitative trends in the acidity of neutral acids.
Strong acids result from stabilized conjugate bases. In other words, for conjugate bases with a negative charge density, these are stabilized by electronegativity, atomic size, resonance, inductive effect, and hybridization. For electronegativity, this trend is observed across a period in the periodic table. The most electronegative element stabilizes the negative charge the best. For atomic size, this trend is observed in a group. For example, group 17, the halogens. The larger ion stabilizes the negative charge the best because the charge is more spread over a larger volume of space. For resonance, electron delocalization is through the pi electron cloud. A conjugated pi electron cloud stabilizes the negative charge. For induction, electron dispersal is through sigma bonds from a nearby electron withdrawing group containing electronegative atoms. For hybridization, the negative charge is stabilized by the most s character in a hybridized set of orbitals. In an sp hybridized orbital, there is 50% s character, while sp2 has only 33% s character, and sp3 orbitals have 25% s character.